Today we're going to talk about the first three examples in section 4.2, graph linear equations. An example of an equation in two variables is 2x plus 5y equals 8. A solution of an equation in two variables, x and y, is an ordered pair, x comma y, that produces a true statement when the values of x and y are substituted into the equation. So, there are many solutions to an equation in two variables. So example 1 says which ordered pair is a solution to the equation 3x minus y equals 7, and we have four choices. Basically, we just need to plug in the x and the y value to the equation and see which one actually works. So if I do 3 times 3 minus 4, if 3 comma 4 is a solution, this will equal 7. When I follow order of operations, 9 minus 4 is not going to equal 7. So choice A is not the correct answer. If I try B, I'll plug in 1 where the x goes. And then this says minus negative 4, which is the same as plus 4. Oh, this one looks like it's going to work. 3 plus 4 is in fact equal to 7. So the correct choice is B. If I try the other two real quick, 3 times 5 minus negative 3 would become a plus 3. That is not going to equal 7. And if I do 3 times negative 1 minus negative 2 becomes plus 2. I have negative 3 plus 2 is equal to 7, which is not true. So B was the only correct choice here. Guided practice number 1 says tell whether 4 comma negative 1/2 is a solution of the equation x plus 2y equals 5. Well, to decide, I'm going to plug in 4 where the x goes and negative 1/2 where the y goes and see if it works. So I have 4 plus 2 times negative 1/2 is a negative 1, and 4 plus negative 1 is 3, not 5. So the answer here is no. The graph of an equation in two variables is the set of points in a coordinate plane that represents all the solutions of an equation. So when you graph a line to represent an equation, every solution that could possibly work in that equation will be on that line. So these are the steps we're going to follow. First, you have to make sure the equation is solved for y in function form. Then you need to make a table by choosing a few x values and filling in the y values. Then you plot the points. Hopefully, if you did it correctly, your points will lie in a line, and then you will connect the points by drawing a line through them and use arrows to indicate that the graph goes on without end. So here's example 2. Graph the equation, negative 2x plus y is equal to negative 3. First thing I need to do is rearrange this equation so that it says y equals. That will make it a lot easier to fill the table in. So I add 2x to both sides. And then I choose my x values. So the graph that we have here is a 4-quadrant graph. It makes the most sense to try to pick a couple negative x values, a couple positive x values. You want to try to pick numbers that are small, easy to do mental math with. So I'm going to stick with negative 2, negative 1, 0, 1, and 2. When I plug negative 2 in, 2 times negative 2 is negative 4, minus 3, negative 7. 2 times negative 1 is negative 2, minus 3 is negative 5. 2 times 0, minus 3. 2 times 1, minus 3. And 2 times 2, minus 3. Once my table is created, I then plot my points. So negative 2 with negative 7. Negative 1 with negative 5. 0 with negative 3. 1 with negative 1. And 2 with positive 1. They are lying in a line here, so I will connect them. I will fill the graph space, and I will put arrows on both ends of my line. In example 3, we're going to be graphing an equation that says y equals 2 and one that says x equals negative 1. These are unique equations. You'll notice that there are not two variables. The first one just has y values. If I try to make a table for that, no matter what x's I pick, my y values are all going to be 2. When I graph that, I end up with a horizontal line that hits the y-axis at 2. This equation has an x value only. So I can't really make a table for this one because I don't have y equals, so I can't solve for y. But knowing that y equals 2 produced a horizontal line that hit the y-axis at 2, hopefully you're thinking that x equals -1 is going to produce a vertical line that hits the x-axis at -1. So I'll throw a few points on there, and then I will connect the dots with a straight line. Here's a key concept about equations for horizontal and vertical lines. A horizontal line is always set up as y equals a number, and it hits the y-axis at 0, whatever that value is. When the equation says x equals a number, it's always going to be a vertical line that hits the x-axis at that point, a, 0. So the graph of y equals b is a horizontal line. The line passes through the point 0, b. And the graph x equals a is a vertical line that passes through the points 0, a. We are going to graph these 3 points. Okay, so I rearranged the first equation so that it says y equals. I subtracted 3x from both sides. And then I chose my x values. I picked -2, -1, 0, 1, and 2. Again, I picked a couple that were negative, a couple that were positive. I wanted them to be small numbers that were easy to do mental math with. I plugged those values into my rearranged equation to get my y values, and then I plotted those 5 points. They do form a straight line, so I will draw a line through them, and I will put arrows on each end to indicate that those lines, that line continues in both directions. Okay, when we go to graph this one, y equals 2.5. I notice that it does not have an x value in it, which means it's going to be a horizontal line that hits the y-axis at 2.5. So we'll start up here at 2.5. You can add a couple of points to the left and to the right to help you make your line straighter, more straight. And then I connect those points and make my horizontal line that hits the y-axis at 2.5. For the equation x equals -4, that's going to be a vertical line that hits the x-axis at -4. So we'll start by plotting the x-intercept, where the line is going to hit the x-axis. I'll add a couple more points in each direction to help me make my line nice and straight. And then I will connect the dots with a straight line and arrows on the end.